All right, hello everybody. This is my recording on project 2. This is going to be the second part, which is dealing with the Excel file. For this part of the project, what we're going to be doing is mostly some formatting and plotting of the instance values, as well as some theoretical calculations. So yeah, without further ado, we'll go ahead and get started. So first and foremost, what we need to do is plot the velocity profile at 25, 50, and 75 centimeters over the flat plate onto the same graph. So in order to do so, we'll go into Excel, an empty sheet, and go to Notepad and collect our values for our 25 and just copying and pasting them into this new sheet for 25, for our 50, and for our 75 here. Okay. And now that we have all these in here and they're all sorted correctly, what we'll do to make this three-way graph is go to Insert, Scatter Plots, and the Smooth Line Scatter Plot. And we'll go ahead and start selecting our data. So for this one, we'll start with the 25 centimeter, and we'll just call it 25. And we'll select our X values here. And then we'll go over here and do the Y values, just like so. Okay, and then we'll go ahead and do the 50. Same process, just selecting the X values here. And then our Y values, like so. And finishing up with the 75 X value and our Y value. Okay, and that should do it. Okay, yep, and then we'll add our legend so we can see, and we'll just call it velocity profiles. All right, so that works for our graph. Now we're going to get our boundary layer thickness. So our boundary layer thickness is just going to be anytime you see that this Y column here just passes this value of 1.98, which is 0.99 times our U infinity, which is 2. So in order to do so, we're just going to go ahead and go here, Y, and then we'll say boundary thickness, and we'll say 25, 50, and 75. Okay, so like I said, just any number, just past this value here. So for our 25, we're looking here. This is just past it. We'll collect this X value here. For our 50, right about here, do the same. And for our 75, right about here, we'll do. And yeah, so that'll be our boundary layer thickness approximation of ANSYS. And now we need to compare them. So in order to do that, we'll go to our theoretical sheet here, which I have pre-made. I just pasted the formulas that we'll be using here, as well as our density, viscosity, and U infinity. Just some helpful values that were given to calculate. So first we'll start with X and getting our X values. So we'll go ahead and start at 0, and then we'll add 0.01 each time, and we'll just go down to 1. There should be enough values. Yep, right there. All right. So for our boundary layer thickness, we're going to need our Reynolds number at X. So we'll go ahead and do that. So our Reynolds number formula is going to be equal to our density, which is 1.2, times our U infinity, which is 2, times our X value, and divided by 0.000018. Okay, and then we should be able to just go ahead and drag that down. You should get something that kind of looks like that. Okay. Now for our boundary layer across the plate. I'll go ahead and select that. Alrighty. Yep, just something like that. Okay. So for our boundary layer thickness across the plate, we're just going to do some moving of the variables. So it's going to be 5 times our x value divided by the square root of our Reynolds number. And we should go ahead and pull that down. Yep, you should get something that looks sort of like this for our boundary layer thicknesses. And then we went to compare these values. So to compare them, we'll go to 25, select that, copy that, and we'll go up here at uses, and then theoretical. Yep, just like that. All right, and then we'll paste just the value here. Oops, did I not grab it? Yeah, and just the value. Okay, that'll do it for that one. And then we'll go down to 50, which is right down here. Copy that, paste the value over, and then we should be able to do the same for our 75. All right, and it should look something like that. Now for the rest of our theoretical, we're going to be comparing skin friction, wall shear, and drag coefficient. So what we're going to do is go ahead and make those just to save us some time later. Friction, like I said, just to save us a little bit of time later on. Okay, so for skin friction, it's going to be right here. So this will be our CF value. So it's just going to be 0.664 divided by the square root of our Reynolds numbers. And then we should be able to go ahead and drag that down and get those values. And then we're going to do our wall shear, which is just that. So for our wall shear stress, it's a little bit bigger of an equation. So what we're going to do here is we're just going to say is equal to 0.332 times the square root of our viscosity, which is 0.000018, times the square root of our density, which is just 1.2, and then times our u infinity, which is 2. So what we'll do here is we'll just say 2 to the 3 over 2. And that's all divided by the square root of our x value. Okay. And there we go. And then we just need drag coefficient, which we can do real quickly. Our drag coefficient is going to be equals to 1.328 divided by the Reynolds number of the entire flat plate, so it's going to be at x equals 1. So what we can do is set this up. So we'll have 1.2 times 2, which is our U infinity and density, times 1 divided by 0.0018. And that'll be our drag coefficient, should be the same. Yeah, okay. So that'll be our drag coefficient. Okay, next, I believe we need to plot our wall shear and skin friction. So to do so, we're going to just make another one. We'll just call this skin friction and one more wall shear. All right, so we'll go back to our notepad. I already have these open, so we'll go to our skin friction and just select these values here and paste them in. We'll just get rid of that real quickly. Okay. As you can see, these are all sorted right, so we are good there. Just real quickly, gonna insert another scatter plot. And for this, we should just be able to select our data here, I believe. Yep, just make sure. Yep. Just call it skin friction. Okay, so there's our skin friction graph. We'll go ahead and do the same for shear, which is going to be in our shear note here. Okay. Same process, just inserting the scatter plot. And we'll select our data. And just change the name wall shear. Okay. And that'll do it there for our wall shear. Next, yep, that'll do it for wall shear. Um, oh, okay, compare that. Okay, yeah, so what we'll do here is to compare them, we'll actually go to our theoretical here and just copy the x values here. Oops. And we'll go to our skin friction. Oops. All right. So we'll just call this instance. We'll move the plot over theoretical. Oops. Must have not correct the values there. Copy them. Skin friction. And we'll just paste the values. I'm going to go ahead and do the same for over here while I have them selected. So we'll call this instance theoretical. Okay. And like I said, while I already have them highlighted, I'm just going to copy and paste them over here as well. Okay. And now we'll go and grab our skin friction values here. Okay. And paste them. And then we'll go and grab our wall shear, which is right here. Oops. Okay. And we'll paste our wall shear here. All right. Now, just like we did before with the velocity profiles, we're just going to select data, add a new row, call this the all theoretical, select our x values, and select our y values, and then we can rename this one as well, and we'll call that answers, just to make it look a little bit better. Okay, and that'll do it for our wall shear, and then we'll go back over to our skin friction here and do the same chart design, select data, add a new one, theoretical, go ahead and grab our x values and our y values, and we'll do the same and just call this in. Okay, and it should look something like that. And we can add our legend for both, and there we go. Okay, and then just to compare the drag coefficients, oops, we'll just set CDs over here. Or we'll go down here. Yeah, that works. All right. Our CD for our theoretical is this value here. And then we should have the CD value in here, the real. And we'll go ahead and grab that as well. Delete the formatting off of that. That'll be 0. And we'll just edit that a little bit. Okay, and there's our comparison for our CD values. And I think that should just about do it. Yep, compare theoretical, sure. Yep, and that'll be it.